Today we're doing 10.5 perimeter and area on the coordinate plane. There's a whole bunch of formulas here. We don't necessarily have to memorize all these. You can if you want. I highly encourage it. It'll help you out and pay dividends down the road. But most all of these can just be derived from the simple rectangle area. So hopefully you all, please tell me you all can do the area of a rectangle. It's just the height times the base. This triangle formula, you can think of it as, I'm drawing it poorly here, pretend like that's a rectangle. The triangle takes half of that rectangle area, right? So it's 1/2 the height of that triangle times the base, where the height is in altitude. The parallelogram is something kind of similar. We can think of this chunk here. If you can break off this chunk and place it right here, then again we just have another perfect rectangle, so it's base times height. Rhombus, you can think of these triangles, right? Each one is, so the rhombus formula here, again, it's a parallelogram, so you could calculate a rhombus using base times height if you're given the base and height. Sometimes you won't be given the base and the height. You'll just be given the diagonal. So this is diagonal 1, diagonal 2. We know that this triangle here, its area is 1/2. In this case, the base, which is diagonal d1/2 times the height, which is d2/2. If you multiply all this, you get d1 times d2/8. And there's 4 of these, so that gives us d1 times d2/2. Similarly, kite and then trapezoid. Sorry, it's in the way. Our trapezoid formula, you can think of that as the average of the two bases, right? That's our mid-segment times the height. Because we can move this triangle here, up here, and this triangle here, we could move up here. So we can clean that up, right? And we're just given the, move that here, put that up there, and all of a sudden we have a rectangle again. So it's the average of the two bases times the height. Okay, you don't really have to be able to drive them all, but if you forget them, you can figure them out. I have confidence in you. Okay, you're going to have to do these in the coordinate plane. So for example, they may just give you these 4 points and say, hey, what's the area of this figure? Totally within our skill set. All we have to do is figure out the shape we're dealing with first, right? So we can figure out the slopes. We can say, oh, hey, is this a rectangle? Oh, they're perpendicular to each other because the slopes are opposite reciprocals, right? We can also figure out that it's a parallelogram because opposite sides have the same slope. So we know it's a rectangle, and then once we know it's a rectangle, we can say, oh hey, all we need to do is find the length of the base, multiply it by the height. We can find both of those using the distance formula, and so we use the distance formula to figure out that one side has the square root of 45, the other side has the square root of 20. Multiply those by each other, and we get 30. Okay, I'm going to skip this one. We can also, just like when I was going over those formulas earlier, we can piece things together in what's called a composite figure. So for example, these are pretty easy to do. Most of you guys can do this. We know that this part of the figure is a square, so that's 4 by 4, that's 16 there. We know that this one here is 2 by 3, so that's, what is that, 1, 2, oh no, yeah, so it's 2 times 3 times 1/2, so that's 3, so there's 3 there. This has an area of 3. This one here has an area of 2 times 4, so that has an area of 4, or 1/2, 2 times 4. And this has an area of 1/2 of 4 times 4, so that's 8. So then we can go 3 plus 3 plus 16 plus 8 plus 4 gives us 34? I think 34. Yay, 34. Okay. And that one's 32. All right, good luck. Have fun.